Build versus buy versus blend. What's the best way of developing a solution? It doesn't matter if you're into firmware, hardware, or software. There's so much that can be learned from this conversation I had with Memfault's CEO. To accompany this discussion, Memfault has produced this neat handbook on buy versus blend versus build, and you can download it by following the link below or going to ipXchange.tech/build versus buy. Hey, it's Eamon with ipXchange, and we're here with another piece of Memfault content, this time an IP experience with Memfault's CEO, François. So, yes, the previous discussion we had was with Gillian, who's a firmware engineer, and she showed me through the Memfault platform and described to me what it was. So I'm going to try and reiterate what Memfault is. So François, you can correct me. So Memfault is an observability platform for connected devices, and it allows you to basically see everything that's going on with the device out in the field and then debug and give it OTA updates to fix those faults. Is that correct?
Yeah, I think that's a great description. I often like to say that we help hardware companies understand how their product is working. And when it's not working, we help them fix it. Ideally, before their own customers notice. But your description was on point.
Cool, excellent. So the topic of discussion today is going to be build versus blend versus buy. And this is going to be in relation to an observability platform. So I think the first thing we need to define is what is observability? Because it's a very useful term, but I don't think many people know it, even though they're going to be thinking about it. So can you define observability for us, François?
Of course. So observability is a term that comes from the software world. About actually a few decades ago now, when software and enterprise software became more and more common, businesses who made that software started wondering, how might we know when the software is having issues and resolve those issues? And that's when the concept of observability was born. Simply stated, it is the idea that by collecting telemetry data and analyzing it, we can quickly identify problems as they occur, and we can get the data we need to resolve the problem without having to get on site, without having to get our hands on the server itself, right? So we applied to IoT and connected devices. It's the idea that we can find out that a device has a connectivity problem or has a battery problem before the customer notifies us by using telemetry data, and then using that data to resolve the issue without having to get the device back in the lab or sending a technician to the customer site.
Cool. So obviously today we're going to be talking about building versus buying versus blending a solution for observability. It's probably also good that we define what is building, what is buying, and what is blending. It may seem obvious, but just in brief. And then let's go over some of the pros and cons for each of them.
Of course. So whenever we have to build a product, the reality is we never build everything from scratch, right? We're not going out in the mountains mining the ore to then cast the metal. I mean, there has to be some amounts that we just purchase from third party. So the idea of build versus buy versus blend is having, a deliberative approach and a thoughtful approach to which parts of our products are we developing from scratch completely ourselves. That would be building. Which parts do we buy? And by the way, buying doesn't necessarily mean purchasing. It means using a third-party piece of software. So it could be an open source package. It could be a vendor. And then, of course, blend is sometimes we do a little bit of both. We might take some third-party solution and adapt it, right? We may, for example, decide we'll start with free RTOS as our RTOS, but we'll make some modifications to the RTOS because we wanted to do some things that the stock version doesn't. And every product employs all three of these techniques: building some things, buying some things, and blending some of them. So although the terms are not always well known, the methods, I think, are very popular.
Okay. So although you've outlined there that people are effectively always blending from
right.
That's what I could understand from what you said. But what are the pros and cons of if say someone did want to develop the whole thing themselves? what are they going to encounter that's good and what's bad about doing it that way?
There's very clear trade-offs, and I think ultimately, it depends on your exact business and product you're building, where you'll want to position yourselves in that trade-off continuum. But when you build something from scratch, it's the costliest option. It's the highest effort, right? Because when you're buying something, you're benefiting from the cumulative effort of a lot of different firms and the cumulative spending of a lot of different firms. And so you only have to, spend an incremental amount to get the whole piece of it. When you're building something from scratch, you don't benefit from that effort. And so it's more costly and it takes longer. It might take, to give you an example, if you were deciding I'm going to build my own email client, it might take you 2 years of work. But if you buy Gmail, you can start using email tomorrow. So it's not only cheaper, but it's much faster, much faster to market. The advantages, however, of building is that it's perfectly to your specification. It is your IP. You don't have complex legal agreements and liability exchange with third parties. It is on your own servers, which oftentimes can be a benefit, especially if you're selling to government or defense customers. And sometimes, there has to be something that you build, right? Like ultimately, your what differentiates you is the piece that you build yourself. And so there has to be some IP that you're created, something unique that only you can do, and that's what you should build. So those are the pros and cons. I'll talk a little bit more about the buy piece. I've talked about the cumulative effort and advantage of, really building on the shoulders of giants when we buy something. The other thing that I think is underappreciated is that when we buy something, we benefit also from the wisdom of many others before us. Because let's say you're going to build, again, your own email client from scratch. You're going to make many mistakes that have been made before by your forebears. If you buy a solution, you buy Gmail or you buy an open source email server, you'll have benefited from the wisdom of people having made the mistakes and corrected them. And so, in a way, it kind of bypasses your own biases and blinders by benefiting from the wisdom of others. So, ultimately, I could talk about this topic at length, but I think it's already a good definition.
Yeah. So I guess key takeaways there are you benefit from the wisdom of others by going with a buy/blend approach. You drastically speed up your development time because it's done for you, and that has cost implications because any development does cost. Is that a good summary?
Absolutely. And I think we often underestimate development costs, right? Like engineers are very expensive. And so 6 months of engineering time is a lot of money, a big expense.
Yeah. Cool. And full transparency to our audience, we Francois and I had a discussion before where we were talking about ARM as a key example of why you don't develop completely from scratch. So, Francois, would you like to expand a little bit more on kind of the ARM comparison to buying or blending when it comes to Memfault and observability?
Yeah, how we got to that conversation is, I was talking about the fact that hardware makers tend to really like to build everything themselves. I talk to many hardware companies. It's my job, right? I meet with folks who build amazing devices. It's really the most fun part of my job. And all of them show me all the custom stuff they're building. I mean, sometimes I'll meet a team and they're building their own RTOS. They have their own C library implementation. They're building their own linked lists. They're doing everything from scratch, But even them, of course, end up buying some things, right? They're not building their own processor. That would be really over the top. They're oftentimes relying on an instruction set architecture. They're relying on chips that are made by third parties. And so really, while we sometimes identify as people who like to build everything ourselves, especially as engineers, the reality is no matter who we are and how sophisticated our products are, we're always integrating third-party solutions. There would be no progress otherwise. It's a big part of human progress. We take the work of others, we build upon it, right? And ARM is such a phenomenal example of that, because there is not, there are very, very few companies who aren't building on top of ARM as in the first place. They're building on top of the chips, but they're also using a compiler, oftentimes developed by ARM. They're using third-party libraries, either from ARM itself or from the semiconductor vendor that they're buying the chips from. So in fact, my estimation is that the average IoT product already has something like 60% of the software that is provided by third parties, a lot of which is provided by ARM and the chip vendors.
Mm-hmm. Cool. So you mentioned there how much engineers like to build everything themselves, and I can relate, but I know exactly where you're coming from, because I didn't. So I've made guitars in the past, but I wouldn't say I didn't make a guitar because I didn't make the neck, for example. But for any engineers out there who say, okay, I could buy a solution, but I only want 10% of what I'm buying, what would you say to them? Do they still benefit from all that cost saving and development saving if they're only developing 10% of what they would buy?
So when we think we need 10%, I think this is a question I get so often. When we sometimes see a solution and we think, oh, my needs are simple. I think I could like grab this piece over there, that piece over there, that piece over there, build just 10% of that solution and get it done in a weekend. It's like almost a trope. If you go on engineer forums, they're like, oh, I could build this over the weekend. And why doesn't that work out? The reason it doesn't work out is a few things. Number one is no matter how little of the full solution you build, it has to be a production ready system. And with that comes, all of the testing, a lot of edge case that you have to handle. Even though you didn't think about them at the beginning, you'll discover them as you're developing. And so making something production worthy is a lot of work, no matter how little of the actual features you build. In fact, it's not possible to do just 10% of the work, because just making a production ready system is probably 30% of the work, right? Number two is all these features are interdependent oftentimes, right? In order to get the dashboards, you need the data pipeline and data engineering platform, and a lot of these things are actually dependent on each other, build upon each other. And so as you start picking one feature at the very top, a nice UI element that you want to see, you'll end up dragging with yourself half of the complexity of the application to make that one UI element do what you want. And so iteratively, incrementally, as you're developing your 10% solution, you'll end up rebuilding almost the entire thing, because you'll realize and you'll learn along the way why all of these things were built the way they were, and they were built together. And so I think there are many, many good reasons for building something in-house, but almost every time it is costs that's driving that decision, you're making a mistake. You're underestimating the costs, you're overestimating your velocity, the velocity of the engineering team, and last but not least, you're underestimating the opportunity costs. Because when your team is busy building infrastructure that is undifferentiated, that isn't different from what your other competitors are doing, this is time that your team is not spending building products that differentiates you. Sorry for the double negative there, but hopefully you follow me.
Because you're reinventing the wheel.
You're reinventing the wheel, whereas you should be innovating, right? You should be spending your time not on building your own email client from scratch. Everyone has email. It all works the same. Instead, you should be spending your time building your products, the thing that makes you unique. And so here in the context of observability, because that's what I'm excited about, in observability is a commodity, right? Like everyone needs a way to collect telemetry and understand the behavior of their device. But that feature itself, that thing itself, isn't going to differentiate you in the marketplace. It's not going to be, you're not going to beat your competitor because you built a better observability system. You're going to beat your competitors because you built a better product. And that's where your energy should be spent. And so that's the case I make oftentimes is if, on this continuum of build versus buy versus blends, infrastructure like observability is, for me, of course, I'm biased, but for me, obviously something that is really well suited to being bought because it's undifferentiated from business to business. It's costly to build, and there is very little prior art you can use, so you end up making lots of design mistakes again and again that cost you along the way.
Cool. And I think one of the key takeaways from what you've just said is probably that 10% of features is still probably more than 50% of the development. I think it is not a linearly scaling thing.
It does not scale linearly, exactly. And that's a really important insight.
Cool. So to play devil's advocate, I'm sure there's people who say that, well, Memfault builds it themselves, so why can't they? And again, I think you already have an answer for this one, but yes. In what way is Memfault not completely built itself?
Right. So I think look at what we do. You're right. At Memfault, we build our own observability system. And so you might say, why are you preaching that we use somebody else's when you're yourself building one? I think that, it's not the gotcha that it seems like it might be, because I will tell you a secret. We use some off-the-shelf observability for our own products, right? We're customers of a product called Hosted Metrics. Neither here nor there, the specific product, but we use Hosted Metrics and we use Sentry. And that's what we use to observe the behavior of our application. Because we're not going to build that ourselves. There's amazing tools that exist off the shelf when you're trying to observe a cloud service, which is what Memfault's product is, a cloud service. So in fact, first of all, we're doing what we preach. We use third-party software when it's undifferentiating. Number one. Number two is we have thousands of organizations who've created accounts on the Memfault platform, and many of those organizations have sent us feedback. They share their wisdom with us, and so we've been able to synthesize the learnings of all of these organizations around observability and build a best-in-class solution. Last but not least, observability is our core business. It's where we are choosing to innovate. It's where it's what we're spending. It's the IP that we are building, and therefore it makes sense for us to be investing this time and energy into it. But if I was making, if I was building a compiler business, I wouldn't be building custom observability. If I was building an IoT product, and I was, by the way, I worked at Oculus, I worked at Pebble. In each of those places, we bought all of the infrastructure we could, building everything from scratch. I mean, we didn't have the engineers to build everything from scratch. We couldn't afford to. It would have taken us a decade to come to market.
Cool. And is there an estimate that you say is the amount that Memfault has built completely in-house? And just out of interest, what would you say is the thing that differentiates you in terms of observability?
I think that in the cloud world, you look at any cloud application out there, and Memfault included, the amount of custom built software is maybe 10% of the overall solution. When you add together the fact, like we use an open source database system, we pay for it to get hosted, but it's an open source database system called ClickHouse. That's millions of lines of code. We use Linux as the operating system that we run on our servers. We use literally thousands of open source libraries as part of our service. So the actual built software in our solution, while it's a lot in terms of human efforts, it's a tiny percentage of the overall solution that we provide. And by the way, I find that as the IoT and the hardware industry becomes more and more software influenced and software heavy, as these devices run more and more software, the percentage of that software which is custom built is going down. because when you
Okay.
were building a tiny PID control loop on a Atmega chipset with 10 kilobytes of code space, you might have built 90% of that software from scratch because it was really so custom and there was so little room to add third-party software on your device. But nowadays, you're building an embedded Linux device. You're using an open source runtime like Go or like Python. You're using all kinds of libraries to do TCP/IP connectivity and encryption and all this stuff. Like, I think we'll find that 10% number is going to become also pretty common in the IoT space, where more and more of the software will be built collectively and open source or by third parties, and less of it will be custom. But that custom piece will be the differentiator. It will be the IP.
Nice. And I think this talk of software segues perfectly into what I wanted to ask next, which is AI is everywhere. So I think we need to cover it in some way. So especially when it comes to generative AI. I mean, I talk to engineers who use generative AI to write code for them. How do you think that's going to affect the balance of build versus buy versus blend? And do you actually see it as a kind of a useful tool at this point, or do you think it's not quite there yet?
So AI is actually pushing on both sides of that equation, and I'll walk you through what I mean here. On the one hand, AI is making the case for even more software being bought than built. And I'll give you the example of large language models, right? If building custom large language models costs hundreds of millions of dollars of GPUs and compute time, because these models are very, very expensive to train. And so really, it's out of reach for 99% of organizations to train their own fully custom large language models. So not only is it very expensive, but also the expertise is rare. There are few people who know how to build these AI systems. And so most organizations, as they look to adopt AI in their products, they're going to build something. They're going to buy something off the shelf, They're going to buy a model. They're going to buy some cloud services. They might buy some consulting services, but they'll have very little of the expertise or the capital in-house to build AI themselves. So that's the one piece of the equation. The other piece of the equation is that I do think AI, slowly but surely, is making development cost of traditional software go down. Because things like copilots are augmenting software engineers' productivity to such an extent that in some cases, it will be easy enough to build something from scratch using AI as an enabler, that some organizations may end up building more internal tools themselves. I don't think it will be building their own email client or observability, but a lot of little internal admin tools or reporting tools that they might have either not had at all, or they might have bought some cheap off-the-shelf solutions. They might end up building themselves using an AI assistant to help them write the codes. I don't know. I can't say that I've seen that happen just yet, but that's what I anticipate happening.
Cool. And I suppose on the other end of things, and yeah, I've got to commend you on that observation about how expensive it is to actually develop AI, but which puts it completely out of reach, out of the build portion of the argument. Yeah, I didn't consider that, and that's very interesting. But getting back to generative AI, within observability, do you think there's opportunities for Gen AI in, say, I guess, automated reports or maybe even automated debugging?
So I think about that a lot, because as you can imagine, all of our customers ask me all the time, what's your AI strategy? I don't know why they ask me, frankly, but they ask. I think it's on their minds. And so, this is a little bit of a segue, but at Memfault, every 6 weeks, we do an internal hackathon. So we spend one day building prototypes and showing off different ideas that we have. And as it so happens, the last one of those was last Friday. And I myself, it's the only time I get to write code these days, because as the CEO, my life sadly is email and meetings and podcasts. But on that Friday,
So
every
it's not
six
all
weeks,
bad.
I get to. It's not all bad. I'm happy to be here. But on that Friday, I get to write some code, and so every time every one of those hackathon Fridays, I end up experimenting with AI features to try to develop some intuition about what might and might not work. And so here's where I am at the moment. I think there's obvious value in using AI to automatically analyze observability data. Like, for example, you could use an AI to tell you why is this error happening on my device, right? The observability system reported an error. You could ask the AI, why is it happening? Or you could ask the AI, are there any interesting things in this error report? So that's one. You could even maybe ask the AI to automatically write some code to resolve the problem if that's possible. So that's one piece, one example. I will say that I've experimenting with some of the off-the-shelf models like OpenAI and others. And today, I don't think they know enough about firmware to do this well for hardware observability. I've not managed to get an output that was useful, at least useful enough that we would deploy it. A second way that it can be used in the context of observability is anomaly detection. I think this is a space where AI has actually been used for a long time now. The idea that if you observe a time series of data over time, it usually has patterns that you can learn. And if those patterns change meaningfully, it's worth investigating. So that's anomaly detection. And there's some increasingly good off-the-shelf solutions that I'm investigating. But oftentimes it's very noisy. Like IoT devices, some of them are very kind of cyclical, but some of them are not, especially a consumer device. Their data looks all kinds of ways because a user will grab it and do something new with it, and the data will look different. And so all your anomaly detection systems will trip, and then they're not so useful. So those are the obvious ones. I haven't found any AI model that does them particularly well yet, but I'm keeping an eye on them. And then there's a long tail of ideas, like you could use AI to automatically name your metrics, or automatically name your dashboards, like translate basically machine data into human consumable data. So I have no doubt that AI is going to be a big piece of observability. And if you look at the cloud worlds, companies like Datadog or Sentry, who do observability for cloud applications, they already have rolled out some of these AI features I'm mentioning. It's just that the models are, I think, more comfortable with Python applications than they are with C firmware. So today, the C firmware is a little bit too tricky for them to deal with still. In fairness, that's also true for humans. I think all humans struggle with the C firmware too.
Cool. So you did touch on it a little bit earlier about what differentiates a company if they did choose to use Memfault as an observability platform. But if we could expand on that a bit, if a company, say, approached Memfault or was looking to implement Memfault and decided, well, if everyone else is using it, then maybe I probably shouldn't. What's kind of your answer to them? Because they might be thinking that they're not differentiating themselves, but I think you already said that that's not where they should be.
Well, I'll say first that today not everybody is using it. And so adopting Memfault makes you an early adopter and gives you a leg up over your competition, right? Like, if we can help you drive down your RMA numbers, drive down the customer support requests, and increase customer satisfaction, increase the star rating of your product on Amazon, or increase the reliability of your product in a factory or in an office building, that will be a competitive advantage for you. Eventually, at least that's what I hope, everyone will use Memfault or a tool like it. I think for me, it feels inevitable. This is why I've spent now 5.5 years of my life in this industry. And when that happens, I think you won't have a choice but to use it, because if you don't, you will be behind, right? You may not buy Memfault. You might use another observability system, which inevitably there will be more. but the concept of observability will become table stakes. I think we're actually on the way to that. We see companies increasingly realize that without observability, they're just expending so much energy to track down a long tail of problems that their customers keep complaining about. It's unsustainable, right? So in my opinion, whether everyone's using it or not, I can make a very compelling case about why you should use it. But that's my job.
Cool. And I guess at this early stage of the game, what does it look like when someone partners with Memfault?
So, companies come to us oftentimes in two different they're in two different moments in their life.
Okay.
Either they're planning to launch a new product, and as they plan to launch that new product, they think, how can we make it so that this launch is as successful as possible? Perhaps in the past they launched a product and there was a big bug or an issue at launch and it was really tricky, right? They spent hours trying to figure it out. Customers got really upset, and so they're saying, never again. What might we do differently? So that's a really good time when we chat. We end up chatting with a lot of companies, and we help them come up with a plan on what kind of data points might you care about at launch. Might you want to know about the battery life of your products? Might you want to know about the stability of your products? Might you want to know about how much network traffic it's seeing, or all kinds of metrics? Some of these products have specific metrics like temperature might be something that matters for your specific products, or frame rate of your camera if you have a camera-based product, right? And we come up with which of these metrics, and we'll help you collect those metrics from the device and build dashboards that show those metrics in real time across your whole fleet, so that you can know whether you're meeting your own benchmarks. What you expected in the lab is you're trying to figure out whether it's playing out in the real world. The other time people come to us is when they have a problem and they can't fix it, right? I'm reminded of a company, I won't name them, but they called us because they had a major problem with a motor that would stall, basically, and the device would stop working, and it would lead to all kinds of customer unhappiness. Basically, the motor would stall in the middle of usage, and then what they want, it's not about making the launch successful. It's not even about, what metrics might we collect? No, they say, help us figure out why this is happening. Help us catch the problem in the act and collect the data and that we need to fix it. Because, some problems are really hard to reproduce, right? Let's say that you have a bug that happens once every 10,000 hours. You'll never reproduce it in the office. Right? Because it would take you 10,000 hours of trying to reproduce it in the office. But if you have 10,000 devices in the field, which is not that many, we have customers with millions of devices. If you have 10,000 devices in the field, one of your customers experiences this problem every hour, right? And so observability, if you're in one of those moments where you have a 10,000 hour bugs, you can't fix it because you can't reproduce it, but your customers keep calling you and are really upset about it because it's a really bad bug, then you need something. And so that's a time when companies call us. They integrate our SDK into their device. That's usually about a few days of work. Then they push a software update that includes the Memfault SDK in their device, and they'll immediately start receiving error reports and telemetry that hopefully helps them fix the problem. In the case of the customer I was talking about, within 3 days of deploying Memfault, they had identified the problem and fixed it. I was really, really proud of that. But we have lots of stories like this one.
Cool. Out of interest, how many devices did they have out in the field for that customer?
I think they're in the 150,000 range. It's a
so the stats were device in their favor.
Oh yeah. If you have 100 devices in the field, you don't need observability, right? You have 100 devices in the field, you can probably go and visit all 100 of these devices once a year. It's just not that much. But most connected device makers have more than 1,000. And when you have more than 1,000, you start talking about law of large numbers.
Cool. So I think this has been a very, very good conversation, and I've learned some stuff which I've been very happy to. I always like to, when we have like these kind of high-level discussions, I always like to pose a kind of question about, okay, so we've got connected devices, we've got observability, where do you see this going in, like, say, 5 or 10 years, and the intermingling of observability within the IoT space?
So the nice thing about my business is that I don't have to guess. As I often like to
Okay.
say, is we take well-established, mature best practices from the software world and we bring them
Hmm.
to the hardware world. And so the software world is like about 10 years ahead of us, right? So if I want to know what the
Okay.
next 10 years look like, I just look at the software people, look at what they're doing, and then that tells me what I'll be doing in 10 years. And so what are things that are clear to me? I think experimentation frameworks, things like feature flags, if you've ever heard of them. There's a business I really
No.
like called Launch Darkly that does feature flag
Okay.
as a service. It lets you basically tweak the configuration of your products or tweak the behavior of your service without having to push updates to your software. Okay. So the
Okay.
idea that you could, like, for example, enable a feature for 10% of your customers by just flipping a switch in the clouds, and all of a sudden 10% of your customers get that feature, and then you can observe how they're doing and whether they're using the feature or not, whether it's working or not, and then you can decide whether to roll that feature out to the whole world, all of your users. That's what we call, experimentation. It's a more agile way of developing software. It's completely a standard nowadays in the software world. If you look at
Okay.
Facebook or you look at Google, I should have
Yeah, I
called
think
them
I've
Meta.
seen some
You
on
look at
LinkedIn.
Meta or Google, they use these techniques all the time, right? Like they
Mm.
tweak the color of one pixel in the app and they try it on 5% of users and then they see what works best to make you click ads, right? I think that the same techniques, experimentation techniques, will come to the IoT, and so I think a lot about how we might eventually enable these kinds of experimentation and iterative mode of development. The other one that I think is really, really going to be huge, probably pretty quickly, is application security. Using observability to secure the IoT, to identify vulnerabilities, to catch, compromised devices in the act. This has become also table stake in the cloud worlds. Like security is very, very important for cloud and mobile applications. In the IoT, we've kind of ignored security for too long. I think you may
Mm.
have heard the joke. The S in IoT stands for security, right? There is no S in IoT.
Yeah,
and
yeah.
and and so I think that is coming to an end. Regulators are bearing down on us and are starting to build rules around security. And so I think that observability as a mean to build more secure devices is obviously in the future and something I spend a lot of time thinking about. I'll spare you another note about AI, but of course AI is on my mind as well. How do we
Hmm.
monitor, observe AI models, and how do we use observability data with AI to build better products? So I have a lot of work ahead of myself, but I'm very excited
Yeah.
about it.
Cool. I think that's a perfect place to sign off. So, uh, obviously, this talk was about build versus buy versus blend, but we've covered a lot more than that. So, just to go back to the topic at hand, can you just summarize in like 3 points the key offering of Memfault in terms of this build versus buy versus blend argument?
Sure thing. So Memfault is an observability system which you use to understand how well your product is working. And when it's not working, you can use Memfault to fix it. Like most technology decisions that you make with your products, when you think about observability, you'll need to think about building or buying something off the shelf. We believe that when you buy something off the shelf, you go to market faster, you spend less money, and you benefit from the wisdom of decades or years of development without having to make those same mistakes again. Of course, when you are there are times when you want to build something yourself when it is very differentiated, when it is the product, it's essential or core to the product you're trying to deliver, and what it is the piece of innovation you're trying to bring into the world. But I make the case that observability and infrastructure rarely is. So I hope that many of you, if I didn't convince you, at least I led you all to think about the topic a little bit. And of course, I want to thank you, Eamon, for your great questions and conversation.
Yeah, no worries. This was really, really fun. And obviously, we've got the first conversation I did with Gillian, which has a demonstration of the platform. So if you want to watch that, I'll put a link in the description. And also, Memfault has their sandbox demo, which basically allows you to play with a demo environment of the platform. So we'll put a link in the description to that as well.
Yeah, go check it out. Memfault.com. We'd love to hear from you.
Cool. There is actually so much more I could talk to you about, Francois. But I think we've rounded off this conversation really, really well. So thank you so much for joining us. And yeah, everyone, we've still got some more content to come out regarding Memfault, and we hope you enjoy it.
Thank you, Eamon. This was fun, and let's do this again soon.
Hey, yo, where my engineers at?